Hey there! In this video, we will go through the basics of path-based testing to get familiar with the preliminaries. We will need them for the constrained path-based testing that is going to be explained later in this tutorial. Let's assume that we are testing a process or a workflow in a system, and the process is documented by a UML activity diagram, which is a standard option for such a case. For simplicity, let's look at the simple eShop example on the slide. First, we convert the UML to a directed graph. Let's do it following the way which is used in the TMAP next, a popular testing methodology in the software industry. We replace decision points with graph nodes and name them by letters. Then, we replace sequences of actions without decision or fork by corresponding graph edges, and we number them. So, we have a more compact directed graph, and all the important elements are named in a much simpler way. Then, we find test paths in the graph. They are actually paths in the graph in the mathematical sense. They start in a starting node of the graph and end in any of the graph end nodes. The number of these test paths and the way they traverse the graph are determined by the test coverage criterion, which we will talk about later. The advantage of the model is that it is simple and compact. However, this model's simplicity is also a disadvantage. There is a semantic gap between the actual system under test and the model, and this may lead to limitations in executing the test paths in the system under test. We will come back to this problem later. If you are someone from the industry, you may skip this slide. If you are someone with a mathematical background in this problem or are just interested in knowing more about it, pause and have a closer look. Now let's go through the most common test coverage criteria because they are very important in this matter. They basically set a strength level of the test paths that a model-based testing tool generates. Stronger test coverage criterion means more test paths and a statistically higher chance of detecting defects. However, the notion of strength here is rather intuitive, and we need to talk about the number of test paths and their properties if we want to be completely exact. Anyway, the term strength will suffice for now. Starting from the weakest one, to satisfy the node coverage, each node must be present at least once in the test set. Such coverage is really for just lightweight tests. The next level is edge coverage, a common standard for low-intensity tests. To satisfy edge coverage, each edge must be present at least once in the test set. Edge coverage is equivalent to test depth level 1 in the TMAP next. If we want to cover test processes even more intensively, we can use edge pair coverage. To satisfy this coverage, each possible pair of incoming and outgoing edges for all nodes must be present at least once in the test set. Edge pair coverage is equivalent to test depth level 2 in the TMAP next. However, using this criterion increases the number of test paths, which means higher testing costs. So this coverage criterion and the following criteria are suitable for important and critical parts of the system. TMAP next also suggests test depth level 3, the principle of which is as follows. For each node, find all incoming edges. For each of these edges, create a sequence of 3 consecutive edges that start with these incoming edges. Each of these sequences must be present at least once in the test set. Then, there are other alternatives when we need to make strong test paths. The most well-known criterion for this is probably prime paths coverage, which requires the test set to contain each prime path in the model. Prime path is a simple path that does not appear as a proper subpath of any other simple path. Sounds complicated? No worries, because these paths are computed by specialized tools, as we have already explained in the previous video. Take a look at the list on the left side of this slide to see how we order these test coverage criteria from weakest to strongest. All paths coverage at the bottom of the list means all possible paths in the graph, which is a rather theoretical option. It's necessary to say that the exact positioning of the test depth level, where the level is greater than 3, and prime paths coverage depends on the particular case, so it is difficult to establish the exact order. Also, we can prove certain relations between test coverage criteria. In some situations, if your test set satisfies one test coverage criterion, it automatically satisfies other weaker criteria. So these are essentials for basic path-based testing. In the next videos, we will dig deeper into what the limits of this technique are and how to overcome these limits by upgrading this technique to constrained path-based testing.